Good morning, students. Today we will discuss about sixth unit psychometry. In this unit, maximum syllabus we will cover first psychometric properties. Just I will explain briefly what is dry bulb temperature, wet bulb temperature, specific humidity or humidity ratio, dew point temperature, degree of saturation, relative humidity, sensible heating, sensible cooling, means air conditioning methodologies, sensible heating, sensible cooling, humidification and dehumidification, measurement of psychometric properties using psychometric chart, and simple problems on psychometric chart itself. How industry is utilizing, what type of psychometric properties they are measuring. They are not measuring all psychometric properties. They will measure only two. One is dry bulb temperature, second one is wet bulb temperature. By using these two temperature, they are measuring, they are extracting properties by using psychometric chart. And that one we will discuss in this unit thoroughly. First of all, what is psychometry? Actually, up to now, air we assumed as a perfect gas. It obeys the Charles law and Boyle's law, natural gas laws, PV equal to nRT. Up to now we assume, but air is not a perfect gas because air contains water vapor, especially in winter we can visualize early morning times, total snow is condensed. Means air contains some water vapor. So air is not a perfect gas. Okay, very good. So air contains water vapor means last unit we already discussed. Water vapor is the pure substance. So the air contains perfect gas plus pure substance. So this is neither perfect gas nor pure substance. So I can't apply the laws like perfect gas or pure substance because it is combination of the mixture. So to study like this subsystems, separate science is required, and that science only psychometry. That's all. The science which is dealing the perfect gas plus pure substance. That is called psychometry. The pressures how we are measuring means pressure of dry air plus pressure of water vapor according to Dalton's laws of partial pressure. The pressure of atmospheric air generally 1.0132 bar. So what are the properties generally? Uh, Interaction of the psychometric property. One science we are studying means science deals with some properties. These are the thermometers. You can see. So any industry we are moving for energy auditing or designing of air conditioning system. They will mention weather station. You visit weather station. Very good, sir. In weather station, one wooden plank clamp two thermometers. One thermometer bulb is covered by wick, wet wick. They are pouring some water. One thermometer is free in atmosphere. That's all. Means general ordinary thermometer we place atmosphere normal condition. The exposed area that is called the shape in bulb shape. That's why that is dry bulb. That bulb is dry condition. Means normal air we are measuring. Normal condition. Whatever the temperature we are measuring, that is called dry bulb temperature. That's all. Second one, wet bulb temperature. The wet bulb temperature, whatever the exposed area is there is a shape is bulb. That's why it's came bulb, wet bulb. That bulb is covered by wick, wet wick. We are pouring some water. Immediately we can't measure the wet bulb temperature. Then after some time, with some velocity air is flowing. That air reaching saturation condition by absorption of this water vapor, then drop in temperature will occur the surrounding air. That temperature is called wet bulb temperature. So to measure the wet bulb temperature means it will take time. First the bulb surrounded air must be reached saturation condition. Then we can measure the wet bulb temperature. Just for any industry, just we are measuring these two temperatures. I want to design cooling tower, the size of cooling tower. The difference between the wet bulb and dry bulb and wet bulb is called wet bulb depression. If more wet bulb depression is there, the size of cooling tower drastically reduces. We can reduce the size of cooling tower. If depression is very less, the size of cooling tower is increasing. Suppose this depression is 0, then there is no use of cooling tower. I'll give some examples also. Suppose in Hyderabad or Rayalaseema, this region, the wet bulb depression is high. That's why simply we are using coolers, more than sufficient for the human comfort, especially in summer. But in coastal region, if you are using cooler, means you will not feel comfort. The wet bulb depression is very negligible amount. So you will not get the cooling effect by using general coolers. So wet bulb depression is a major driving force for designing of so many items, especially cooling towers. It is depend on the wet bulb depression. Next, one more property. These two properties, common properties, every industry we are measuring. Simple also, with 150 rupees or 200 rupees investment, we can measure the temperatures. Next, specific humidity or humidity ratio. The mass of vapor present to the total mass of air. How much mass of vapor is presented to the total mass of the air is called specific humidity or humidity ratio. Maximum mass of water can hold at 1 atmospheric pressure is 0.030 kg of water vapor per kg. 0.030. That's a very less amount. If more amount of the water it is capable to hold means, like Jammu Kashmir, we are reaching -20, -30 means ice walls will create. Maybe 1 gram or 2 gram or 3 gram, means 3 kg, 4 kg per kg of air it is capable to hold means, then ice walls will create. But that is not happening. 0.03. This is the maximum. Normally the range is 0.0102 to 0.020. This is a common range of specific humidity in the air. Next, dew point temperature. Once we are cooling the air, we already decided air contains some water vapor. This is already mentally clear. But when we are reducing the temperature of the air, at one particular temperature, the air unable to hold that moisture. At one particular temperature, air unable to hold the moisture, then condensation of the air, moisture in the air, water vapor in the air will initiate. That point is called dew point temperature. At what temperature the condensation of the moisture in the air will take place, that is called dew point temperature. What is the use of dew point temperature? Suppose I already mentioned coastal region having the high moisture content. Wet bulb depression also very low, I already mentioned. So for the human comfort, I want to remove the moisture in the air. That is the main driving force of air conditioning. I want to remove means at what temperature, up to what temperature I want to cool the air is required. So first you determine the dew point temperature. So suppose 20 degrees is the dew point temperature, means first you cool the air up to 20 degrees. After cooling the air 20 degrees only, your condensation of the moisture will take place, water vapor. Then what is the comfortable range? Then after again you heat the air and send for air conditioning. So dew point temperature is major driving force where the relative humidity is high, specific humidity of the moisture is high. How we are determining dew point temperature? Meanwhile, I will explain. Next, Degree of saturation. Simply, this is the ratio of humidity ratio of specific heat, specific humidity. It is the ratio of specific humidity divided by specific humidity at saturation condition. Mass of water vapor per total mass of air divided by mass of water vapor per total mass of air at saturation condition. This is called degree of saturation. Next, relative humidity. This is mass of water vapor divided by volume of air. Only difference is there. Degree of saturation and relative humidity. Relative humidity, mass of water vapor divided by volume of the air divided by mass of water vapor volume of the air at saturation condition. This relative humidity also major driving force for the designing of the air conditioning system. Enthalpy, we know, flow, internal energy plus flow work. How we are determining the enthalpy of air means enthalpy of dry air plus enthalpy of water vapor. Or by using psychrometric chart directly we can calculate the enthalpy. This is the psychrometric chart representation. Directly I will show the psychrometric chart. It is easy for explanation. You see, this is the psycho chart. Y-axis contains specific humidity. I already mentioned 0.030 maximum. Kg of vapor, water vapor divided by kg of air. X-axis is the dry bulb temperature ranging from -10 to 40, 45, 50, 55, 60. -10 to 60 degrees. This is x-axis contains dry bulb temperature, y-axis contains specific humidity. Next, this is the saturation line. This curve is called saturation curve. Means relative humidity is 100. Next 90, 80, 70, 60, 50, 40, 30, 20, 10. Up to relative humidity 10 is there. These are the relative humidity lines. Sorry. It is moved. Next, these are the inclination lines. You can see high level inclination. This inclination lines is called wet bulb lines. -10 to 30. Wet bulb lines. The extension of the wet bulb lines where it is intersecting this enthalpy. These are the enthalpy values. 20 to 100. I think 95, 100, 105, 110, 150 kilojoules per kg. Maximum enthalpy of the air at atmospheric pressure only. These all are atmospheric pressure condition. Next, one more inclination lines are there. These lines are specific volume lines, meter cube per kg. So I think maximum we represented wet bulb temperature, enthalpy, dry bulb temperature, specific humidity or humidity ratio, relative humidity also. But we are not represented dew point. That is very important. I already mentioned. Suppose at 20 degrees temperature and what happened? Maybe 20 not, maybe 40. It is easy. 40 degrees temperature and this 20 relative humidity. 40 degrees temperature, 20 relative humidity. What is the dew point temperature? Your temperature is 40 and relative humidity is 20. 20 is very less. 30 and 40. It is okay. Yes. 40 degrees temperature, 40 relative humidity is generally in Hyderabad or Rayalaseema region. General condition. 40 degrees temperature and 40 relative humidity. Where the intersection is taking place. This is the 40 relative humidity lines and this is the 40 degrees dry bulb temperature. This is the intersection. Now you move horizontally upon the saturation line. Just you move horizontally upon the saturation line. Then that point, what is the dry bulb temperature. Then the dry bulb temperature is 25 degrees. 20, 25, 30, 35, 40. 25 degrees. So the dew point temperature is 25 degrees centigrade. So by using psychrometric chart, if you know two properties, means you can determine any property. Okay. Generally, now up to now we discussed about the psychometric properties and how to extract the psychometric properties by using the psychometric chart. For air conditioning maximum our target human comfort. Human body like a heat engine, it is continuously emitting, rejecting or emitting heat. Heat engine feeding is fossil fuels, so human body feeding is food. That's all. That is the only difference. Uh, the average adult male generally at the time of sleeping also is rejecting 87 watt heat while doing our general office work 115 watt or physical exercises 230 watt heavy works in workshop labor 440 watts in mining anyway, heavy works doing people. This is the heat rejection. So first target in air conditioning to remove that heat for the human comfort. Based on the working condition, the heat content is changing. One is we remove the heat, means control the temperature. Control the temperature, not reduction of the temperature. For ladies, around 15% is less than the adult male. This generally is not exact values based on the body mass index. The values are changing. Second one, I already mentioned relative humidity, moisture in the air. If moisture in the air is high, every respirative body continuously emitting sweat. If body is alive, it is continuously emitting sweat, means moisture on the skin. So continuously we want to remove that moisture, then only that body will come into a comfortable zone. Air conditioning. So maintenance of the relative humidity in the air is important. Means moisture content in the air is very much important. That relative humidity range generally 40 to 60 we are maintaining. Yeah, especially in hill stations already it is 40 to 50 only. We don't want to change anything. Directly we can use that air, just cooling the air and use air for the air conditioning. But in coastal region that is not possible. Coastal region you want to remove the moisture. And third thing I already mentioned, based on the working condition, the heat rejection is high. Heat rejection is high means removal rate also we want to increase. Means the volumetric flow rate of the air we want to increase and decrease. Velocity of the air. Why? Because area is fixed duct area, we are not changing. So volumetric flow rate I want to increase means increase the velocity of the air. So these three are major driving force for air conditioning system. So how best practices we can made for human comfort means I already mentioned just cool the air, reduction of the temperature, sensible cooling it is called. Just heat the air like Jammu Kashmir like that areas. Just you heat the air. Next one, remove the moisture dehumidification or add the moisture humidification. These are the four process. Again this four process combination you can achieve different types of the methodology air conditioning process. I will show the process. Maximum this six process we are using. One is sensible cooling. Second one is sensible heating. Next cooling and humidification. Heating and humidification. Cooling and dehumidification and heating and dehumidification. These are the six methods we are following for year-round air conditioning system. maybe 2 combination, 3 combination, according to the ambient air condition. How we are deciding the ambient air condition? Just we are measuring dry bulb temperature and wet bulb temperature. By using psychrometric chart, we are extracting remaining all properties. So one by one I will explain by using the psychometric chart directly. Then we will get clear idea. See, sensible cooling. Just I am reducing the dry bulb temperature. How I can reduce? Just in vapor compression refrigeration system or vapor absorption refrigeration system or vapor adsorption refrigeration, whatever the technology. Just you place evaporator coil inside the room, automatically you will get the cooling. Just simple cooling, sensible cooling. Then what are the changes are takes place? The dew point temperature is not changing, it is fixed by sensible cooling, and the specific humidity or humidity ratio is not changed. How much moisture is there? That moisture quantity, mass of vapor by mass of total air is not changing by sensible cooling. And but relative humidity is changing. For volume of the airflow rate, the moisture content, the relative humidity is increasing. By just sensible cooling, relative humidity is increasing. Enthalpy is reducing. Why? Because temperature is reduced means automatically enthalpy is reducing. These are the wet bulb temperature is reducing. This is the changes of sensible cooling. How we are achieving sensible cooling is simple. I already mentioned. Just you place evaporator coil inside the room, you will get the sensible. Next one, sensible heating. In the sensible heating, just you place condenser coil inside the room and place evaporator coil outside. You will get heat pump. Indirectly, this refrigeration unit is act as a heat pump. We are placing condenser coil inside the room, automatically you will get the heating. In the sensible heating, you see, the dry bulb temperature we are increasing, but dew point temperature and specific humidity ratio is not changing. But the relative humidity is reducing by sensible heating. For drying operation, what we are doing? We are sensibly heating the air before sending the air inside the dryer chamber, because relative humidity is reducing. Low relative humidity air will absorb more moisture from the agriculture produce, the product which one we want to dry. Next, the wet bulb temperature, it is increasing by temperature, by sensible heating. But enthalpy is increasing. You are increasing temperature means enthalpy is function of temperature. Automatically enthalpy is increasing. Relative humidity is reducing. Next one, cooling and humidification process. I want to cool the air and humidify air. Just our coolers, domestic desert coolers. What we are doing? Wick. We are arranging wick. We are continuously pouring the water, cold water. Automatically the air flowing through the wick, absorbing the moisture. One is humidification is taking place. Second one is the cool air. That's why the temperature also reducing. Reduction of temperature and increasing of the moisture. Here the specific humidity or humidity ratio is increasing. By adding moisture, the humidity, specific humidity or humidity ratio is increasing. Relative humidity is increasing. Sorry. Yes. Relative humidity ratio is increasing and enthalpy is increasing because we are pouring mass of vapor. So vapor having the high enthalpy, automatically enthalpy is increasing even though temperature is decreasing. Enthalpy is increasing. The dew point temperature also increasing. We are increasing the dew point temperature and we are increasing the wet bulb temperature. Okay. But dry bulb temperature is reducing. How we are achieving? Just to pour the atomized cold water on the flowing of the mass flow, volumetric flow of air. We are pouring, we are spraying atomized cold water, cooling and humidification. Next, heating and humidification, same method. Here we are increasing the temperature and we are increasing the moisture content. The specific humidity ratio is increasing, relative humidity is increasing, enthalpy automatically will increase. We are adding moisture and we are increasing the temperature also. How means hot water we are spraying. or atomized water we are spraying. For that purpose, we are using some wick, and the wick continuously we are pouring the water. The air is moving through the wick, automatically it will absorb the moisture. So simplest method, heating and humidification and cooling and humidification. Very less investment. Next, cooling and dehumidification. I want to cool the air and remove the moisture. I already mentioned. In this point, we require dew point temperature. This is the dew point temperature. First, determine the dew point temperature. Mark the initial condition, maybe 40 degrees and 40% relative humidity or 50% relative humidity. Then mark the point and move horizontally to the saturation line. We will get the dew point. Less than the dew point temperature, then only the moisture condensation, removal of the moisture will take place. That is called dehumidification. So cool the air below the dew point temperature, then only we will get the. For this purpose, simple. Our refrigeration system plays evaporator coil, but reduce the temperatures. Generally, human comfort we are assuming 26 plus or minus 2 degrees. Here you want to move based on the dew point temperature. Dew point temperature is 20, means you want to maintain the that air conditioning temperatures are 16 degrees. Then only removal of the moisture will take place. Then after again it is exposed without insulation duct. Again that cool air we are flowing means automatically it will absorb some heat and will reach more than 20 degrees and it will give the human comfort. But 16 degrees temperature air we are flowing inside the room means again a human will not feel comfort. 26 plus or minus 2 degrees are required. Okay. Next one. Heating and dehumidification. For this purpose, separate discs we are using, that silicon gel and alumina Al2O3. High porous media, non-reactive chemicals indirectly. It is not reacting with the air. That non-reactive chemicals. While air is flowing, that humid air is flowing upon the disc, the porous it is highly porous material, it will absorb the moisture. Due to this frictional operation, temperature will rise and it will remove the moisture, but after some time it will reach saturation condition. At that time we want to replace the disc, and this disc we want to heat up to 150 degrees. If silica gel means 150, Al2O3 means more than 200 degrees. We are heating means again desorption will take place. Same disk we can use for operation. So based on the air moisture content, the number of disks are required. Every time you want to change the disk. In this operation, you see you are increasing the temperature. Second one, removing the moisture. The specific humidity is reducing, relative humidity is reducing. The enthalpy is somewhat is increased because the temperature we are increasing. Enthalpy major driving force is temperature. Automatically it is increasing the temperature. The dew point temperature also reduced due to reduction of the moisture. These are the methods, the combination of the methods we are using for the year round air conditioning. This one thoroughly we will discuss in next applied thermodynamics, refrigeration and air conditioning subject. Some of the problems, not problems, some of the give how to extract the properties from the psychometric chart. Just we will practice, then we will get the clear idea utilization of the psychometric chart. The first condition you see here, consider air water vapor mixture at 0.1 megapascal. 0.1 megapascal means 100 into 10, you will get the bar, means 1 bar. 0.1 megapascal equal to 1 bar. Maximum it's a psychometry chart to deal with the atmospheric pressure only. Whatever the units they may convert to kilopascals, megapascals, like that atmosphere pressure. But generally it is at 1 atmosphere pressure only. And 35 degrees dry bulb temperature and 70% relative humidity. So two properties they will give in problem. One is any two proper. One is here they given dry bulb temperature and relative humidity. We want to determine remaining wet bulb temperature, specific humidity, dew point temperature, enthalpy, remaining all properties we want to determine. So first move to the psychometric chart. First condition 35 degrees. Where is the 35 degrees? You see 20. Sorry. Okay. So 35 degrees, 35, 40. Dry bulb temperature is 35 degrees. Okay. And relative humidity is 70%. You see, this is 100, 90, 80, 70. Where the intersection is taking place. This is 70% relative humidity line and this is a 35 degrees temperature line. This is the intersection point. First mark the point. That's all. You move horizontally where the intersection happening. You see on saturation line. At that point, what is the dry bulb temperature? 25, maximum 28.5 something. This is less than 30 degrees. 25, 28.5 degrees. This is the dew point temperature. Next, what is the specific humidity ratio? The specific humidity ratio, you see, this is 0.020, 21, 22, 23, 24, 25, 26. 0.026. This is the specific humidity ratio, kg of kg air. Two properties determined. Next, what is the wet bulb temperature? Is around same. This is the wet bulb temperature line. Same by using scale, same inclination you maintain, you will get maybe more than 30 degrees, maybe 30.5 something. Same line you extend upon the enthalpy, you will get enthalpy 95, 100, more than 100 kilojoules per kg enthalpy. Completed. All properties are completed. Again you see dew point temperature 28, wet bulb temperature 30.5, specific humidity ratio 0.026 and enthalpy 102, more than 100 I mentioned, 102 kilojoules per kg. Simple. Just one more problem we can solve. One atmospheric air is at 35 degrees centigrade dry bulb temperature and 80 relative humidity. One is 35 degrees centigrade, second one is 80 relative humidity. Calculate specific humidity and dew point temperature. You see, same, mark the point. Sorry. Yes, you see. Where is 35 degrees temperature? This is the 35 degrees temperature line and 80 relative humidity. This is 100, 90, 80. 35 and 80 where the intersection is taking place. This is the intersection point. What is the specific humidity? 0.029. Maximum 0.030 kg of vapor by kg of air. 0.029 specific humidity of the air. Next, dew point temperature. Just extend the line upon the saturation curve. Then what is the dry bulb temperature? Is around 31 point something. You see, same answer you will get. 31.5 specific humidity ratio 0.029 kg per kg of air. Generally in industry what they are measuring? They are not giving relative humidity. Why? Because the relative humidity measuring instrument somewhat costly. First thing. Second thing, highly the measuring error is too high. Sensor the sensing repeatability very somewhat low, so we can't rely on relative humidity instrumentation. So better we are measuring dry bulb and wet bulb only. So based on the dry bulb and wet bulb, we will solve two problems. Then we will get a thorough idea about how to use the psychrometric chart. First one, atmospheric air at 1 bar and is at 25 degrees centigrade dry bulb temperature and 15 degrees wet bulb temperature. The dry bulb temperature is 25 degrees centigrade and wet bulb temperature is 15 degrees centigrade. Calculate relative humidity and specific humidity of the mixture by using psychometric chart. Simply you see, dry bulb temperature 25, this is 25 dry bulb temperature, and 15 wet bulb temperature, minus 10, 0, I think 5, this is the 20, 15, 10, 5, 0, minus 5, minus 10. This is the ratio. So 50 degrees wet bulb temperature, same inclination line, and 25 degrees dry bulb temperature, where the intersection is taking place. This is the intersection point. What is the relative humidity at that intersection? This is 40 percentage. 40, not 40, 30 percentage. 90, 90, 80, 70, 60, 50, 40, 30 percentage. This is the 30 percentage relative humidity. This is 30 percentage relative humidity. Simply. So just to mark the intersection lines, where the intersection is taking place, mark the point. At the point, what is the relative humidity? That's all. This is 30%, 20%, 10%. And second problem, you see, atmospheric air at 1 bar and is at 35 degrees centigrade dry bulb temperature and 25 degrees wet bulb temperature. Calculate the dew point and enthalpy of mixture by using psychometric chart. So they are not mentioned relative humidity, but we determine the relative humidity also. First of all, dry bulb temperature 35, wet bulb is 25. You see, the dry bulb temperature, where is the dry bulb temperature? 35. Wet bulb temperature is 25. This is the 20, 25, 30. This is the 25 line. Dry bulb temperature is dry bulb temperature is 35. Wet bulb temperature is 25, 20, 25, 30. This is the intersection point. The relative humidity above 40. Above 40, the intersection point, this is the 40. Above 40, maybe 42, 45 we can write. Relative humidity is around 45 percentage. Next, what is the dew point temperature? Horizontally you move on the saturation line. At that point, whatever the dry bulb temperature is there, that is the dew point temperature. Maybe it is around 21.5 something dew point temperature. And what is the enthalpy? Same wet bulb line extend to the enthalpy line. 70, 75, maybe 76 something. 76 something kilojoules per kg. 76 kilojoules per kg. Dew point temperature 21. This is above 20, 21. And relative humidity is 45. So these are the simple problems, not problems. In this unit, just how to extract the properties, we discuss what are the psychometric properties, how many methods are there for air conditioning system to achieve the human comfort. What is the human comfort targets? One, continuation generated heat removal, means maintain, control the temperature, not decrease or increase. Second one, control the humidity in the air, the relative humidity range 40 to 60 percentage, and based on the human being working, the rate of heat rejection is changing. Based on the rate of heat rejection, the flow rate of the air is important. The volumetric flow rate of the air is important. But duct to area is fixed. That's why velocity of the air we are concentrating, we increasing and decreasing. If heavy workshops is there, what we are doing, the velocity of the air is increasing. Our general office works, the velocity of the air we are reducing. Because ultimately, while designing the air conditioning system, less maintenance cost is main important. Operation maintenance cost drastically we want to reduce. Electrical bills we want to reduce. So to maintain these three parameters optimized manner for achievement of the human comfort. What we'll do. So next applied thermodynamics thoroughly designing of the air conditioning system for summer, winter we will discuss and we will solve some problems also. With this, I am ending this unit, psychrometry. Thank you very much.